and that's it so far. All right, so what we're going to look at in here is the idea of a horizontal asymptote, and I'm going to show you what that is and then the two ways that you can find that. One way is just learn a rule. The other way, the first thing I'm going to do on this is I'm going to show you a technique that gives you a horizontal asymptote. Then I'm going to explain what a horizontal asymptote is anyway. Okay, so what I want you to do first of all is just write down the function I gave you, 3x plus 1, and leave a little gap under that, x minus 3, because we're going to divide every term in this problem by the highest power of x. Now, if you look at your problem, all you have is x to the first. If you had an x to the second, you would divide by whatever the highest power of x is. So what I want you to do is take every term and divide it by x. And I'm only going to do this one time. This is not that important for college algebra students. It's very important for calculus students, but I want to just show you one technique. Then I'm going to teach you rules. I'd expect you to probably just learn the rules on this. Okay, then what we're going to do is we're going to simplify this stuff. So the x's cross out there. So that's going to leave 3. 1 over x, just write it down. And then x over x is 1, so that becomes 1. And then 3 over x, just leave it alone. Okay? Now what I'm going to show you is we've simplified the expression. Now what we're going to do is we're going to let x get big. Okay? Now this is a simple concept. I want to just get my calculator and show you this on the calculator. So if I did this part of the problem, if I did 1 over x, let me show you what happens. If I put in like 1 over 9, I get this. If I do 1 over 99, I get this. If I do 1 over 999, I get this. What's happening as the denominator gets bigger? It's getting closer to 0, isn't it? Okay? And you could get, if you put in like a humongous number in there, it would just have more and more 0.000 things. It would never be perfectly 0, but trust me, it will eventually approach that value of 0. So what you do then in this problem is this thing right here and this thing right here, they go to 0. Okay? So that goes to 0, that goes to 0 like that. So then the final result is we would just say 3 plus 0 over 1 minus 0, that's 3 over 1, which is equal to 3. Okay, like that. So what we're going to say then is the equation of the horizontal asymptote is y equals 3. And remember, we're doing a horizontal line. Anytime you have a horizontal line, that's y equals whatever number it goes through, like that. All right? So that's how you do this. Now I'm going to put this graph on the calculator so you can see what in the world I'm talking about. Okay? You aren't going to have a clue what I'm talking about unless you look at a graph. Okay? So if you want to do this with me with your graphing calculator, just do this. I would recommend you do this with me. One of the things that you want to do, if you're doing, we're going to put this function in, that's incredibly important, is put the numerator in parentheses, put the denominator in parentheses, and then we're going to do this in a standard window like that. I see students all the time, they don't put parentheses around the numerator and denominator, and it's not the right graph. Okay, you've got to get the calculator to crunch out the numerator and denominator separately. Okay, now I'm going to go zoom 6. Okay, and then this is going to come out. Okay, that's what the graph looks like. Now I would like you to do one more thing. Okay, we're going to go back to y. This time go to y2 and put in the horizontal asymptote. Okay, like this. Okay, so we're going to do that. Just get those two things in. Now graph it. And I'll show you what a horizontal asymptote is. Okay, so what you want to see on this is, notice that as x is getting bigger, isn't the graph just kind of leveling off towards that asymptote? Okay, if x gets smaller, isn't the graph just leveling off? That's never going to touch y equals 3. It's just going to get closer and closer and closer to it. Okay? Now, one other good thing to show students on this, like if you want to try this, if you have a table, so if you go second graph, this just gives you a table of values. So I want to just kind of scroll through this and show you what happens. I want you to look at the y value. You've already kind of got the idea, but do you see as x is getting bigger, that y is just getting closer to 3? Okay, and if you scroll down there as far as you want to, if you get bored, you could do that for like a couple of hours. It still wouldn't be at 3, it would just be closer to 3. So that's the idea. Does that make sense? So horizontal asymptotes are kind of a limiting value. As x gets bigger or x gets smaller, it's what the graph levels off at. Does that make any sense? Okay, so that's what horizontal asymptotes are. Okay, let's do one more problem this way, and then I'm going to teach you the rules. Okay, you'll appreciate having the rules because you don't have to go through this whole thing again then. So on this problem, let's first of all start by writing down the function. Leave a little gap because you are going to divide by the highest power of x. Okay, so what do you see as the highest exponent? X to the second. Good. So what we're going to do is we're going to divide each term of this by x to the second. Okay, always work with the highest exponent. Okay, like that. Okay, now what we're going to do is we're going to simplify this a little bit. So if you do this piece right here, you can do that in your head, but it's really x over x times x, so what happens? X crosses out, so you're left with 1 over x. Okay? 1 over x to the second can't be simplified. Okay, if you go to the bottom, this piece right here is going to be 1, right? Because anything divided by itself is 1. This piece right here, again, is going to be 1 over x. And then this piece right here is going to be 5 over x to the second, like this. Okay? So the same idea applies to this. The idea is if you have a number, and that number could be anything, over x, when x gets big, okay, then this whole expression goes to 0. You know, you could even have like a million in the numerator, but what if you had a million in the numerator and a 1 followed by a million zeros, like a huge number in the bottom, it would still get close to 0. Does that make any sense? So the idea is, regardless of what the numerator is, as long as the denominator gets bigger and bigger and bigger, you go to 0. So the idea is going to be on this problem is this thing is going to go to 0. This thing is also going to go to 0. It's going to go to 0 faster because you're squaring the denominator, which makes the number get bigger faster. Still goes to 0. 1 just stays 1. That goes to 0. That goes to 0. Now, if you simplify this, if you write this in a simplified form, this is going to be 0 minus 0 over 1 plus 0 minus 0. That's 0 over 1, so it's equal to 0. So that means the horizontal asymptote is y equals 0. Okay, does that make any sense? Okay. Now, if you do take calculus one day, you'll study about what's called limits, and this is kind of an idea of limits as x goes to infinity. It's kind of a calculus topic. Let's do this one on the graphing calculator, then we'll move on and I'll teach you the rules on this that'll make this a little bit easier for you, okay? Because I would expect you probably, when you're working this out, to just learn the rules and do it that way in this level of a class. Okay, so I'm going to do this. I'm going to put in the function. So I'm going to put in x minus 1, like this. Then I'm going to divide by, and see, make sure you got that parenthesis around that. Always have that, general rule of thumb. Then the bottom is going to be x squared plus x and minus 5. Like that. We'll just do this in a standard window, and that should be good enough. Okay, just get it put in like that. I'm going to go zoom 6, graph it. Let's observe the graph and see if this makes any sense to you. It's a little hard to tell on this, but if you look at this piece right here, see how it's leveling off? Okay, and y equals 0 is actually the x-axis. So it's leveling off at the x-axis. So again, if you went second graph and looked at your table, notice what's happening. As x gets bigger, where is y going? Can you see on the table? It's getting closer to 0, right? So x gets bigger, y gets closer to 0. Does that make sense? Okay, it's just like the last problem got closer to 3, this one's going to get closer to 0. Okay? All right, you guys got any question about that? What that means? Okay. All right, now I'm going to teach you the rules. So let's go on to the next page here and kind of see what we got going on that then. Okay, so here's the rules that we're going to go through. Okay, there's actually 3 rules. So it turns out if you want to find the equation of the horizontal asymptote, there's 3 possibilities. Okay, first of all, if the degree of the numerator is less than the degree of the denominator, the asymptote's y equals 0. Okay, that's what that means. Now let me scroll up to the previous page to show you that, because we did that in the last problem. Okay, what would you consider to be the degree of x minus 1? 1. What would you consider to be the degree of the bottom? 2. So 1 is less than 2, right? So the degree of the top is less than the degree of the bottom, so that's what that rule says. Okay, that's easier, isn't it? Okay, you can do that in like 2 seconds. Okay, then the next rule says if the degree of the numerator is equal to the degree of the denominator, then it turns out to be the ratio of the leading coefficients. So let me scroll up to this example we did here. Okay, what would you consider to be the degree of the top? 1. How about the bottom? They are equal. Now check this out. The leading coefficient of the numerator is 3, right? The leading coefficient of the denominator is 1. So 3 over 1 is 3, right? There it is. It's staring you right in the face. So when you see that, 2 seconds, you got your horizontal asymptote. Okay, now we'll do some more examples of this to kind of demonstrate this then. Okay? All right, so let's do these examples here. And then the third one just says, the third rule just says, if the degree of the numerator is greater than the degree of the denominator, then we do not have a horizontal asymptote. We will have, in some cases, what's called an oblique asymptote. We'll talk about that a little later. Okay, so what is the degree of the numerator on example 1? 2. It's the highest exponent. What's the degree of the denominator? 2. Did I just say 2? Yes, 2. Okay, they are the same. So that means the answer is y equals, and what you do is you look at the leading coefficients. So what is it? Good, 3 halves. So y equals 3 halves is it. Problem done. Okay, that's important when you're dealing with rational functions. Okay, all right, next problem. What's the degree of the numerator? 1. How about the degree of the denominator? 1. They are the same. So what's the answer? Y equals what?
1 over 3.
Good, 1/3. Okay, there's 1, there's 3. Again, remember what you're doing is you have that. Those are the leading coefficients. See how easy that is? Okay, simple rule. Okay. Right, now let's go down and look at the next one here. Okay, oops. Okay, example 3. Degree of numerator is 1, degree of denominator is 3. Okay. Since the degree of the numerator is less than the degree of the denominator, the answer is automatically y equals 0. Okay, that's how you know that. So you don't have to crunch out dividing by the highest power when you do that. And then the last problem, the degree of the numerator is 2, degree of denominator is 1. This time the degree of the numerator is greater than the degree of the denominator, so that means we don't have 1. So that's every possibility there is. Nothing else is possible. Either they're the same, they're less, or they're greater than. So it's very simple if you get the rules memorized how to figure that out. And that's an important part of a rational function when you're learning the structure of the graphs then, like that. Okay, any questions about that? Okay. All right. Now, an oblique asymptote, I'm going to work on that a little bit. Okay, an oblique asymptote is going to occur if the degree of the numerator is greater than the degree of the denominator by 1. And we're only going to look at it when it's bigger by 1. So an example might be you have a function like x to the third plus 1 over x to the second plus x minus 1. Okay, this is 1 bigger than that, so it's going to have an oblique asymptote. What an oblique asymptote means is it's just a line. So your asymptote doesn't have to be a vertical. It can be a line, and then as the graph goes to infinity, it approaches that line. So it may kind of swing up, something like that. You'll see what I mean when we actually start looking at some graphs, okay? All right, so let's look at this kind of situation. Okay, this is just a graph. These are just asymptotes, okay? How many vertical asymptotes are there? They're represented by dashed lines. There are two. There's one there, there's one there. So this is x equals -2, and then this one is, looks like x equals 6. Remember, vertical lines are named by the x value because they go through the x value. Okay? How many horizontal asymptotes do you have? Just one. Okay, it's this one. Okay, you name that by y equals, and that's going to be y going through -2. We have that, and there is no oblique asymptote because that's a slanted line. So oblique asymptotes, sometimes we call those slant asymptotes. Okay, all right. Now this one I think was supposed to say equation of vertical asymptote. I think that's a typo on my part. So we don't have one. And horizontal asymptote, we don't have one. But we do have an oblique asymptote. That's because it's a slanted line. So you know that a line has the form y equals mx plus b. So if you're going to figure out what that is, you need to look at the y-intercept, which is, I can't even tell what that is. Let's just use an educated guess. I'm gonna say it's 1. I don't know. That's what I think it's probably what I meant. Okay, so let's say that the y-intercept's 1. And I think this thing right here is probably a point, so let's count the slope. So if you're going from, this is 1, 2, 3, 4, 5, so it looks to me like you're going up 4, then it looks like you're going to the right 1. You guys see what I mean by that? I think if you got, it's up 4, right 1, if I'm counting that right, I think I am. So that means the slope is going to be 4, so that means the oblique asymptote's equation is y equals 4x plus 1, like that. So that's just a matter of identifying the slope and y-intercept to figure out what those two things are, okay? So that's what your oblique asymptotes look like and your horizontals like that, okay? Remember, vertical lines are x equals something, horizontal lines are y equals something, okay? So you got to name these as equations. Okay, now we're going to put all the graphing kind of together here and kind of put it all together. What we're leading up to is how we graph these things. Okay, so again, with this one, this is just kind of an overview of what we've been doing. Rational functions look like this. They are fractions. The numerator is a polynomial. The denominator is a polynomial. They are ratios of polynomials. Okay, these are two examples of rational functions. Okay, a vertical asymptote occurs when the denominator is 0. So in this case, if you solve that equation, you would have a vertical asymptote at x equals 4. There would be a vertical line. The function's undefined there. That's a vertical asymptote. And then the other thing on this page is just kind of a summary of what I just taught you, is these are the rules for horizontal asymptotes, so you want to make sure you know those, okay? The other thing we haven't done yet, but we'll do an example of this, is if you have a rational function that's factored like this, okay? This is probably a real important thing to just write a note of here. Since this cancels, and then that would be x equals -2 is what's called a hole in the graph, and we oftentimes call that a deleted point. And I'll explain what that means once I do a graph with an example. The one that cancels is not a vertical asymptote, it's just a hole in the graph. So you'll have a graph, and that'll just be a bubble right there, okay? The one that's left over is the vertical asymptote. So you would have a vertical asymptote at x equals -5. So you see that every now and then. If something cancels, that x plus 2 cancels from the denominator, it's not an asymptote. So that's something that you've got to be kind of cautious about when you're looking at these things then, okay? All right, now what we're going to finish up with this section is we've kind of been going over the background so that you can go through and do the graph. So I'm going to teach you how to do graphs with and without a calculator. So let's start with this example right here of a rational function, okay? Also, this kind of thing, guaranteed test question, absolute guaranteed, just like this. I give a rational function, you give the parts, you do the graph without a calculator. You don't need a calculator. Calculators are good checking tools. Okay, so let's look at the equation of the horizontal asymptote. So what you do is you do these two things. You look at the degree of the numerator. What's the degree of the numerator on this problem? It's the highest power of x, right? What is the degree of the denominator? 1 also. Okay? They are the same. So the answer to this horizontal line, which is y equals, is staring you right in the face. What is it? It's 2 over 1. Okay? I realize you're just learning this, but if the degree of the numerator are the same, it's the ratio of those two numbers. So that's really, of course, 2 over 1. Okay? So that would just be y equals 2 over 1. So that would be y equals 2. Okay? That's how you do that. Okay? Now what we want to do is find the equation. Let's go down and find the equation of the vertical asymptote. So what you always do on this is you set the denominator equal to 0. Okay, the denominator is x minus 1. Set that equal to 0. You can solve that equation in your head, and you get x equals 1. So whenever you're doing these graphing a rational function, to me that's the starting place, is you always want to start by doing that. Oops. Come on down. There we go. All right, so let's go ahead and let's put those things on there then. Okay, so as I go through this, let's go ahead and put the horizontal asymptote on there. So what you need to do is you need to just draw a horizontal line through y equals 2. And make sure that you dash it. Okay, you always dash the asymptotes. And then let's label that as y equals 2. We have a vertical asymptote at x equals 1. So you want to go ahead and draw that line that is going through x equals 1. Like that. So you always want to start these problems by figuring out if there's any asymptotes and graphing them. Okay? All right. Next step is we want to figure out what the x and y intercepts are. Okay? When you do an x-intercept, you always do x-intercepts the same way. What you do is you set the function or the y value equal to 0 when you solve the equation for x. Regardless of the function I give you, it's always the same thing. So what we're going to do is replace that f of x with 0. So we have that's equal to 2x plus 6 over x minus 1, like that. Now when you solve an equation with fractions, what do you typically do? You typically get rid of the fraction, right? So if I multiply both sides of this equation by x minus 1, that wipes that out. Okay, so that's what you typically are going to do on these problems is that. Now the left side is going to be 0 because 0 times anything is 0. Then the right side is going to be 2x plus 6. So you solve that equation. So again, set the function to 0, solve the equation. That's how you find x-intercepts. Okay. And then this one you can subtract 6 from both sides. Do that in your head if you want to. Negative 6 equals 2x. Divide by 2. So you get x equals negative 3. Okay, so that means your x-intercept is the point negative 3, 0. Okay, so let's go ahead and let's put that point. So go to your x-axis, go to 3, and just put a dot there. Okay, so that will be our x-intercept like that. Okay, all right, so far so good. All right. Just got to know what to do. Okay, all right. Now the y-intercept, what do you do to find the y-intercept? X equals 0. Good. You set x equals 0. Okay, so we're going to set x equal to 0. So you just go to your function. You're doing f of 0. Y-intercepts a lot of times you can do in your head. So you just do 2 times 0 plus 6 over 0 minus 1. Okay, that's going to be 6 in the numerator. Negative 1 in the denominator, so that's negative 6. Okay, so we have a y-intercept now of the point 0, negative 6. Okay, that's what y is when x is 0. So you want to go on this problem, you want to go through and go down to negative 6. 1, 2, 3, 4, 5, 6. So I think I'm there. And then we got it. Okay, like that. So we got asymptotes and we got 2 points. Now we're going to do this problem totally without a calculator. The next part is the part that a little bit more of a learning curve to it. So what we're going to do is we're going to make what we call a sign chart to figure this out. And we'll do the domain and range as soon as we're done with the graph. That's because it's easier to do that at the end just by looking at the graph. So when you do a sign chart, one thing that you might want to write down is you always use X-intercepts. This is a way you break your sign chart up. X-intercepts or vertical asymptotes. Those are the things that you look at. You don't look at anything else. So we're going to make a sign chart. One of the reasons I like to do sign charts a little bit too in this class is because if you do take calculus one day, you do this a bunch, you know, for a different context, but you certainly learned how to do that, okay? All right, so here's what I would like you to do when you're learning how to do these sign charts. Just draw a line, straight line, okay, like that, okay? Draw a line. Wasn't that cool? It even has arrows on it. That's so cool. You got to admit, okay? All right, so now what do we have? Do we have an X-intercept? Where was the X-intercept? -3. Okay, so just put a -3 there. And then just put a little dashed line through there. Okay. We had a vertical asymptote. Did we have one of those? That was at 1. And see, a vertical asymptote tells you where the function's undefined. So I like you to put U's there. Okay, just kind of develop that habit. Okay, so here's what we're going to do on this. I'm going to write down I need to go back up and get the function. I forgot what it is. 2x plus 6 over x minus 1. Okay, so watch how I do this, and watch what I'm going to do on this problem. Okay, what we're going to do is what we call a test point. We're going to plug a test point into the function and see if it's negative or positive. So give me a number that is smaller than -3. You read my mind. -4 is what I was thinking about. Okay, so plug it in. Do 2 times -4 plus 6 over -4 minus 1. And all you care about is whether it's negative or positive. Don't waste your time on this. This is -8 plus 6 over -5. So don't you really have a negative over a negative? So it's a positive. Just put a positive there. That's it. Don't take the time to crunch out what the answer is. Just figure out if it's negative or positive. Now what that's going to mean and what that tells you is it means that the graph is above the x-axis. That's what that means. So we can use that information to draw our graph. Okay, once we get to doing the graph, I think this will help you understand this better. Okay, so what I did is I take a test point, plug it in, and just care about whether it's positive or negative. Okay, right, now give me a number between -3 and 1.
0.
That's what I was hoping somebody'd say. 0 is my favorite number to calculate with. I love 0. Okay, it's easy. But it doesn't matter what you pick, by the way. You'll always get the same result. So we're going to go -2 times 0 plus 6 over 0 minus 1. The numerator is 6. The denominator is -1. Is that negative or positive? That's all you care about. Okay? That means that the graph is below the x-axis. That's what that tells you. So when we do our graph, you'll see that. It'll be very clear to you, I think. Okay? Now give me a number bigger than 1. 2. Okay? If you gave me 1,000,000, it would still work. So we do 2 times 2 plus 6 over 2 minus 1. Again, plug that 2 into the function. So it looks like you get 4 plus 6 over 1. That's a positive over a positive. That's a positive. That tells you that the graph is above the x-axis. Okay, so that's what that means then. Okay? All right, do you guys see what I'm doing on that sign chart okay?
Yeah.
Get the gist of it? Okay, now we're going to put together the graph on this then. Okay, so here's what you do. First of all, if you're below -3, see here's -3 right here. If you're below -3 over here, that means the graph is above the x-axis. And since you have a horizontal asymptote, that's going to mean you're going to draw this part of the graph like this. And you're going to just make it approach the asymptote. It will not cross the horizontal asymptote. It never will. As this graph, as x gets smaller, what's y going to get close to? 2. That's what an asymptote does. Okay? And see, we're above the x-axis. I made sure I drew that above the x-axis. All those y values are positive. Okay? Now between -3, which would be that's -3, and 1, we said we're below the x-axis. So what we're going to do is we've got to go like that. We have to connect, and then we don't touch the asymptote. We just get close to it, like that. That's the idea. You never touch asymptotes. You get close to them. Okay? That's why I like to say, kiss my asymptote. Okay? Because it gets close to it, but never quite reaches there. It's not a very good kiss, but it gets very close. Okay? Like that. Okay. Now, above the x-axis. Now, the way this goes is you have to do this. When you're above 1, you're going to be above here. Now, if you have a vertical asymptote, you're always going to either go up infinitely or down infinitely. The only thing that would make sense is to go up infinitely, because you have to be above the axis. When you're at a horizontal asymptote, you level off. So what you do is you just kind of sketch that in, and that's good enough. That's not very accurate, but it's good enough. Okay, so basically that sign chart told us enough information to get a good graph. Does that make any sense? Yeah. The sign chart is the biggest learning curve that you have to do on this. And then what I'd recommend you do on any of these problems as you're learning this, just put it in your graphing calculator. So let's put that in. So I'm going to go y equals parentheses 2x plus 6. Then I'm going to divide by x minus 1. Just do it in a standard window. Another thing that's a good thing to do is to put in, if you have a horizontal asymptote, just put it in. You don't have to, but it's a good thing to do. Now I'm going to go zoom 6, and let's see if this is the same thing we drew. Look at that. It is. How about that? We didn't touch the calculator. We only touched it for checking. Okay, so it's the same thing. Roughly, okay? And you don't have to have that much accuracy. If you want to get more points, then you just kind of plug them in, and that's good enough. Okay, does that make sense? Yeah? No? Yeah. Okay. All my classes today, I can tell they're ready for spring break, because I ask a question and they're like, they just give me this funny look on their face. All right. Okay, so let's move on to the next. Let me do the domain and range. I forgot to do that. Okay, so the domain, is there any value that x can't be? Well, it can't be 1. Okay, so you would have to say -infinity to 1 with a parenthesis, union 1 infinity, so you'd have to go like that. The range, the only value that y never hits is 2. So you have to say -infinity to 2, union 2 to infinity. Okay, remember the horizontal asymptote, you can see from my graph, it's never going to touch y equals 2, right? Because of the asymptote. It's never going to touch x equals 1 because of the asymptote. So it's everything but those two values. Does that make sense? Okay. All right, so domain, like we've learned, is x. Y is range, like that. Okay, so let's move on. Let's do one more, then we'll take a short break here. Okay, so let's do this one. This one's pretty standard. Okay, the first thing that you probably want to do on a problem like this is, if you look at the function, first of all, can you factor the denominator? Yes, factor it, okay? That's something that's real important. If you see something that factors, go ahead and factor it. So that's the difference of two squares that goes x plus 2, x minus 2, like that. Okay, so that's how that's going to go. Right, so we're going to do the same kind of strategy on this. If we do a horizontal asymptote, you care about the degrees. So the degree of the numerator on this is 1. The degree of the denominator is 2. So since the degree of the numerator is less than the degree of the denominator, the rule that we learned is that y equals 0 is that asymptote. Okay? Unlike the last problem, that's how that goes. Okay? Now, when you find vertical asymptotes, what you do is you look at the denominator and you see what makes it 0. Okay, and there's nothing that crosses out. We're not there yet. So in your head, what would make the denominator equal to 0? Yeah, 2 and -2. Just solve those two equations and do it in your head. Okay, so that is, you have two of them this time. You have x equals -2, and you have x equals +2. So those are your two asymptotes that you have then. Okay? So what you're going to do is you're going to go ahead and you're going to put all these asymptotes on here. So we're going to have a vertical at x equals -2. So you need to go ahead and just kind of write that in. That's one of your asymptotes. Use dashed lines when you do that. Okay, then you got another one at x equals 2. So you want to dash that in. Okay, and then we also had one at y equals 0. Now y equals 0 is the x-axis, right? So you just sort of put a dashed line kind of by the x-axis, just to kind of help you, remind you that the x-axis is an asymptote. You can't see that very good, but you know it's there, okay? So that's how you do asymptotes. Asymptotes are always done the same way. Verticals is where's the denominator 0. Horizontals are those rules I taught you is the easiest way to do it, okay? Now if we do an X-intercept on this part C, what I said you do on that is you set f of x equal to 0. Okay, you always do that. Okay, so when I do that, we're going to have set f of x equals 0. So I'll just do this kind of at the side here. We're going to have 0 here equals x over x squared minus 4. You have an equation with a fraction in it. You'll kind of learn to do this step in your head a lot of times on these things. So you multiply both sides by x squared minus 4 to cross that out. So now notice what you'll have is you'll have this side is 0, this side is x, so you get x equals 0. Now that's always done the same way, so your x-intercept is 0, 0. Okay, so that means that you're going to have a dot right here in the middle. Now, isn't that also a y-intercept? It's on the x and y at the same time, so you could bypass this. It's got to be the same. It has to be. Or you could do this. If you did f of 0, all you're going to get is 0 over 0 squared minus 4. That's equal to 0 anyway. Okay, so when you do y-intercepts, that's what you do. Okay? Okay, any questions so far? Okay, now I'm going to go down and we're going to do this sign chart next here. Okay, so let's go through on this then, and let's put together our sign chart. So just draw a line. You always just go through and draw a line when you're doing a sign chart, and you're analyzing if the graph's above or below the x-axis. Okay, so just do that. Now, the thing that you always want to make sure that you know on this is you always want to use x-intercepts and you want to use vertical asymptotes. You don't care about anything else. So you have a vertical asymptote at -2. You have an x-intercept at 0. Now, I like students when they have a vertical asymptote to put u's. Okay, this is an x-intercept, so just put kind of like a dashed line. You are defined there. Then you have 2, and then you're going to have undefined there then, like that. Okay? Now, it's all going to be about test points is what we're going to do. Okay? So let me go up and get that. It's x over x squared minus 4 is what we're looking at. Okay? So let's put this together then. So we're going to have x over x squared minus 4. Okay, let's do the test points. It's a little bit time consuming to do this, but with a little practice you can do it pretty fast. Okay, I'm going to take a number less than -2. Let's use -3. Okay, I like to draw a box around my test points because it helps me write answers in a certain way better. Okay, all right, let's plug it in and let's see what we get. So when we do this, we're plugging into this function, so we're going to have -3 over -3 squared minus 4. If you can tell me whether it's positive or negative in your head, that's all I care about. You're really going to have -3 over 9 minus 4. Is that negative or positive? It's negative. Okay, it's -3 over 5, right? What does that tell you? It tells you the graph is below the x-axis. Okay, that's the meaning of that. Okay, all right. Now let's go to the next interval, -2 and 0. Let's pick like -1. Okay, any number will work as long as it's in that interval. Plug it in. So we're going to have -1 over -1 squared minus 4. So notice that's going to be a -1. That's really 1 minus 4, so it's -3. So what is that, positive or negative? Positive. That's all you care about. So that means you are above the x-axis. Okay. Now move on to the next interval. Let's use 1 and see what we get. So we're going to plug in. We're going to have 1 over 1 to the second minus 4. In your head, is that positive or negative? That's negative. It's right. It's 1 over negative 3. So that's negative. That means we're below. Okay. Now go to the next interval. Let's go to 3. Crunch it out. That's going to be 3 over 3 squared minus 4. Is that positive or negative? It's positive. So that tells you you're above. All right. Now don't fall for this. Students a lot of times say, well, the signs alternate. So they assume they're going to alternate. No, they don't. Depends on the problem. They don't always go negative, plus, minus, plus. Sometimes they can go plus, 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 plus. You have to crunch it out. You have no choice. You don't know how it's going to go unless you work it out. Okay, so don't fall for them. So now what we're going to do is we're going to do a graph. The graph is usually what students have the most trouble with. Basically, when you're below negative 2, the graph is below the x-axis. Your graph is in this area here. Now remember, what I said is you level off towards asymptotes. Vertical asymptotes, you either go up or down. So you just do that, and then you connect it kind of in that shape like that. That's good enough, okay? For a sketch of the graph, it's going to have that shape, okay? Remember, it levels off, and will either go straight up or straight down when you have a vertical asymptote. Now, between negative 2 and 0, it said we're above. Okay, so that means you got to go like this. You got to be above the x-axis, but you have to approach that asymptote like that. You have to. You see what I mean? Okay, you must approach verticals either up or down. You must approach horizontals just level off. Okay. Now it said in the next interval between 0 and 2 you're below, so that's going to do something kind of like that. It has to. Doesn't touch the asymptote, it just gets close to it. Okay. And then in the last interval, when you're bigger than 2, it's going to be above. So your graph has to be strictly above the x-axis. What's going to happen to the graph as it approaches the vertical asymptote? What's it going to do? This. It has to. And what's going to happen as you approach the horizontal asymptote? It's going to level off. And then just connect them. It doesn't have to be 100% accurate. You just got to have a sketch. Okay? And then that would be the graph on that. That would be your solution then. Okay, does that make sense? Yeah.
For the line in the middle, how do you know if it goes up or down?
Okay, well, if you look at the sign chart between negative 2 and 0, look at my sign chart, negative 2 and 0, you're above. Okay, so you have to be strictly above the x-axis. And since you approach the vertical asymptote that way, you have no choice than just to kind of draw a curve kind of like that. You have no choice, okay? You can't do anything else, okay? Same thing with this part. You know, between 0 and 2, you're below the x-axis, right? And you have a vertical asymptote, so you have to go approach that asymptote like that. It's all how you approach the asymptotes is what you got to understand. Okay, now the domain. Is there anything on this problem that x couldn't be? Negative 2 and 2. Good. So you just say negative infinity to negative 2. Union, negative 2 to infinity, union 2 to infinity. There was 2 places that made you have a 0 denominator. Okay.
Negative 2 to 2. Yeah.
Oh, thank you. Yeah, that's not right. Okay. Negative 2 to 2 is what that would be. So you got negative 2 to 2 like that. Okay. Now look very, very carefully at the graph. Okay. Let's look at this part right here that I'm highlighting. Did that touch every y value? It did. It even touched that right there. So the range is all real numbers. Even though you have this asymptote, you can still cross an asymptote. You can cross a horizontal asymptote. You just can't cross it infinitely that way and infinitely that way. That's how horizontal asymptotes behave. So then the range on this would be negative infinity to infinity like that. Look at your graph. Okay, it's okay to touch horizontals. It's just not okay to touch them way out there and way out there. Does that make sense? Yeah. Students always ask that question, and that's a good question. So I'll take care of it then. All right, well, let's do... So this is one other thing that can happen. This will be done in a similar way. There's one thing. You want to pay attention to this one because there's one little tricky part of it. Okay, first thing that you always want to do on these problems is if anything factors, factor it. So notice that the denominators, or the numerator is going to factor. You can take a 3 out of the numerator, so you're going to have 3 times x plus 1. Then you can factor the denominator. That's a trinomial, which is going to go x and x, 1 and 2, with the 2 being minus and the x being plus. Now I'm going to write this over here because I want to show you something. So you want to be sure on a problem like this, and I say this all the time to students, is if you factor something, make sure that you factored it right. Because if you don't, you're just wasting your time with going through and finishing the problem, right? Don't waste your time. All right, so here's what happens. The one that cancels is going to be a hole in the graph. It's just like a bubble, or we call it a deleted point. Okay, so we're just going to say we have a deleted point at x equals -1. And again, what I'm doing is I'm taking the one that canceled out and solving that equation, which you can do that in your head. Okay, well, the one that's left over is a vertical asymptote. So we're going to kind of work 2 parts of this problem out in one step. So again, you take x minus 2 equals 0. That gives x equals 2. So that would be the equation of your asymptote, like that. Okay, so you got that. That's kind of an important thing to look at, is if you see something factors, you want to be sure that you go ahead and just, factor that out and everything. Okay, all right, now let's look at the horizontal asymptote. When you look at a horizontal asymptote, you look at the degrees. The degree of the numerator is 1. Okay, so we'd have the degree of the numerator being 1, and then the degree of the denominator is 2. So that means the degree of the numerator is less than the degree of the denominator. You remember which one that is? Yeah, y equals 0. Okay, you'll get that down once you study that a little bit. It's just, that's what you look for. We're not going to do much with oblique asymptotes in this class. I'm just going to do things with horizontals and verticals. Okay, now this is the other thing you got to pay attention to. Okay, X-intercept, what I said, is to set the function equal to 0. But it is wrong on this problem to do this. You just want to make a note of this. That is wrong. The reason is because something canceled out. Okay, don't set the original equal to 0. Set whatever you're left with equal to 0. Okay, you'll get a wrong answer if you do that. So that's super important that you do that. Now this is a weird equation. Okay, you have a fraction, so what you're used to doing, of course, is multiplying both sides by whatever it takes to get rid of that. Now what in the world happens on this? This crosses out, gives you 3. That's like 0. That's weird. Well, it happens sometimes. That just means that equation has no solution, so it's going to mean that we don't have an x-intercept. Okay, that's a weird thing that happens sometimes. Okay, so you got to set the reduced form equal to 0. It just happened on this problem that you're not going to have a x-intercept because that doesn't generate an equation. Okay, now when you do a y-intercept, you always set x equals 0. So we're just going to go to the function, and again, same thing. Just don't go there, go here. Okay, go to the reduced form. So we're going to say f of 0 equals, and just go here with what's left over. So we're going to have 3 over 0 minus 2. So that's 3 over -2. So that means the y-intercept, x is 0, y is -3/2. So we've got that, everything taken care of basically in the problem that we need. Everything that we have, we've got the asymptotes, we've got the intercepts figured out, and then we have this deleted point, and I'll kind of explain how that goes here in just a minute. Okay, is there any questions about that? Okay, now I'm going to go down, we're going to do a sign chart, we're going to do one more sign chart. By the end of class, you'll be sick of these sign charts because everything we do in the next section also has to do with sign charts, but that's a good thing. I don't care if you're sick of them, repetition is good. Okay, so we're going to go down and we're going to draw a line. Okay, and you got to know how to set these things up. So really what I said always is you use x-intercepts if you have any. You use vertical asymptotes if you have any, and that's it. You don't look at anything else. Okay, now if you look at this problem, I've already forgot. We had no x-intercepts, right? But did we have a vertical asymptote? I already forgot.
Yes.
What was it?
Yeah, not sir.
I can't hear a thing. So let me do this. X equals 2. Now I heard you. Okay, so we have x equals 2. So that's it. And that's all we're going to do on this problem is we're going to have x equals 2 and that's undefined. We don't care about anything else. That's it. No x-intercepts. Don't worry about it. Okay. All right. So now your problem on this one is you're dealing with the function f of x equals 3x plus 3 over x squared minus x minus 2. And when we did that in a reduced form, I think we ended up with 3 over x minus 2, right? After we reduced it. Okay. So let's use this instead of this in here. You would actually get the same result if you did your test points there, but it's a heck of a lot easier to use that. So just use it. So let's do our test points like we've been doing and kind of figure this out. So let's do 0 there. That's a number that's less than 2. Plug it in. So you're going to have 3 over 0 minus 2. That's 3 over negative 2, which is a negative number. So that means you're going to be below the x-axis. Okay, so when we draw our graph, we're going to be below the x-axis. Okay. Now let's take a test point bigger than 2. Let's say take 3. Plug it in. Plug the 3 in there. You're going to have 3 over 3 minus 2. So that's 3 over 1. That's a positive. That means you're above the x-axis. Okay, you guys getting the gist of this sign chart stuff? It's arithmetic. You're plugging test points into the function, okay? And it tells you whether it's above or below the x-axis, okay? So what I want to kind of do on this now, I'm going to zoom out on this thing just a little bit so I can see everything, all right? So what we need to basically do on this is we need to put two things on here. We need to go ahead on our graph, and we need to go ahead and put the asymptote on there. So let's go ahead and put, we have a vertical asymptote at x equals 2. So let's go ahead and put that in. Again, you write a dashed line when you do that. Okay, like that. We also had a y-intercept that was negative, it was 0, negative 3 halves. Well, that's really 0, negative 1.5. So just kind of estimate where negative 1.5 is, like that. So you have a line like that. Now, the sign chart will tell you how the graph goes. And there's going to be one little exception that we'll talk about. So the idea is going to be, according to our sign chart, whenever you are less than 2, which is right here, x equals 2 is the asymptote, where are you? You're below the x-axis. In your mind, imagine what happens. What's going to happen at the horizontal asymptote? It always levels off, right? So it levels off. What happens at the vertical asymptote? You have two choices. Either it goes up or it goes down. Which? Down. Okay, the reason it can't go up is because if it did, it would be above the x-axis. That's how you distinguish between the two. So what you do is just kind of sketch it in like that. Kind of sketch that in like that. That's beautiful. That's not totally accurate, but it's good enough. So we are totally below the x-axis, and we approach the asymptotes the way we needed to. Remember, you had a horizontal asymptote on this problem of y equals 0. Okay? Now, when you're above 2, when you're bigger than 2, you're above. So you're going to be, the whole graph up here is above. Where's it going to go with a vertical asymptote? Is it going to go up or is it going to go down? It's going to go up. It has to. And then what's going to happen at the horizontal? It's going to level off. And then just kind of sketch it in. And okay, as long as you got that shape, that's good enough. Now, the only other thing that we had on this problem is I think we had a deleted point. Where was that deleted point? Was that x equals negative 1? Now, this is all I'm going to have you guys do. It's good enough. So what I want you to do is we're going to take I'm going to take like my red marker. And when you go to negative 1, I just want you to draw a bubble. Okay, right there. Just put a bubble. Okay, it's there. Okay, the graph is undefined there, but it's not an asymptote. It just means the graph is smooth and connected, but you are undefined right there. So that thing right there is called the deleted point. Okay, just a bubble. So there's two places on this graph where it's undefined. That's the idea. Okay, does that make any sense? Yes, no? Okay. Deleted point's just a bubble. It's not an asymptote. Now, when you do the domain, there's two places where you're undefined. You're undefined at -1, so x can't be -1. You're also undefined at 2. So we just say on the domain, we can say -infinity to -1, union -1 to 2, union 2 to infinity, like that. So you're undefined at 2 places. Okay, look at the range on this. Is there any value of y that you never hit? There is something.
Yeah.
Good, 0. Okay, you know that it's never going to touch the horizontal asymptote unless it touches somewhere kind of in the middle. It never does. So y is never going to be 0. So what we can say on that is -infinity to 0, and then union 0 to infinity, like that. And that's it. Now, I would recommend, you know, when you're learning this, the domain and range, just kind of look at your graph and see if you can reason it out from there, because you can. Domain is what x is, range is what y is, like that. That's the idea. Okay. Does that look any good? Halfway, at least?